Today we will continue looking at two-step equations. These are equations where we perform two inverse operations on the unknown variable in order to solve them. So let's get started. So when we solve equations, our goal is to get the unknown variable, in this case it's x, on one side of the equal sign with a coefficient of 1, so 1x, and then everything else is on the other side. And this gives us the value of x that when we plug into x will make the left side of the equation equal to the right side of the equation. For this equation, x is divided by 3 and also 5 is added to x. So we're going to have to undo addition and undo division. And the order we want to do this in is we first want to undo any addition or subtraction, and then we undo multiplication or division. So we have x divided by 3 plus 5. So to undo that addition of 5, we subtract 5 from both sides. When we do this, we end up with x over 3 equal to, and then 7 minus 5 is 2. This leaves us with x divided by 3. So to undo that division by 3, we multiply both sides by 3, resulting in x equal to 6. We'll check our answer by plugging in that value for x. So wherever there's an x, we'll put in a 6. So we have 6 divided by 3 plus 5 equal to 7. 6 divided by 3 is 2. Plus 5 equal to 7. And then 2 plus 5 is 7. We end up with 7 equal to 7. And that is a true statement. For the second problem, we have 13y plus 4 plus y is equal to 32. Now first we want to simplify down both sides of the equal sign separately. So we're going to look at this left side. Are there any like terms that can be combined? Any arithmetic that can be done? Yes, we can combine 13y plus y. Those are like terms. So 13y plus y, that's 14y, plus 4 equal to, and then there's nothing on the right side that can be done. So this is 32. And now we'll do step 1. We'll undo that addition by subtracting 4 from both sides. That gives us 14y equal to 28. And then we'll undo multiplication by dividing both sides by 14. And we end up with y equal to 2. Checking the answer, we always go back to the original equation when we check our answer, just in case we made a mistake early on. So we have 13 times 2 plus 4 plus 2 equal to 32. 13 times 2 is 26, so 26 plus 4 plus 2 equal to 32. And then 26 plus 4 is 30, plus another 2 is 32, so 32 equal to 32. Now it's best practice to undo addition or subtraction first before undoing multiplication or division. You're going to be doing PEMDAS, or order of operations, in reverse. However, it's not a requirement. So for this problem, if we did order of operations in reverse, so we have 2 times x plus 7 is equal to 19. So the first step we would do is to undo this addition. So we're going to subtract 7 from both sides. We end up with 2x equal to 12. And then, undoing that multiplication or division, we will divide both sides by 2. And we end up with x equal to 6. However, this is not a requirement to do things in this order. In most cases, solving the equation by first undoing addition or subtraction followed by undoing the multiplication or division is the best way of doing it. But you don't have to follow that order. So let's do this problem in a different way. So we have 2x plus 7 is equal to 19. So again, ideally, you would undo addition first. But let's undo this multiplication step first. So we have x multiplied by 2. That means we're going to need to divide both sides by 2. Let's go ahead and rewrite this left side. So we have 2x divided by 2 plus 7 over 2. And notice we're now introducing fractions into this equation. These 2's are going to cancel out, and we have x plus 7 halves equal to 19 halves. So now we're going to undo the addition with subtraction of 7 halves from both sides. That gives us x equal to, then 19 minus 7 is 12, so we have 12 over 2, and that is x equal to 6. So we end up with the same answer. By undoing multiplication first, using division, we did introduce fractions into solving this equation. And then checking our answer, wherever there's an x, we'll put in a 6. So we have 2 times 6 plus 7 is equal to 19. And then following the order of operations, we're going to do multiplication first. So that's 12 plus 7 is equal to 19. 19 is equal to 19. So again, let's solve this problem here using two methods. In the first method, we will undo addition or subtraction first. And in the second case, we will undo multiplication or division first. So we have 1/3 x plus 7/3 equal to 5. So if we're undoing addition or subtraction first, we're going to subtract 7/3 from both sides. And notice we are subtracting fractions. That leaves us with x over 3, or 1/3 x on the left. And now we have to find a common denominator in order to do this arithmetic. So we have 5 and 7/3, so the common denominator will be 3. So that's going to give us 15/3 minus 7/3. And then doing that arithmetic, we have x over 3 equal to, and then 15 minus 7 is 8, and we have 8/3. So now we have to undo the division. We'll do that by multiplication. Multiply both sides by 3, and we end up with x equal to 8. But now let's do this same problem in the opposite order. We're going to undo multiplication or division first. So we have x, and it's divided by 3. So that means we are going to multiply both sides by 3. So we multiply the entire left side by 3 and right side by 3. So we'll use the distributive property. That'll give us 3 times 1/3 x plus 3 times 7/3. And that's equal to 15. These 3's cancel out. We get x. And then these 3's cancel out. We get 7. So x plus 7 is equal to 15. And then subtracting 7, we end up with x equal to 8. Same answer. Checking our answer, we'll get 8/3 plus 7/3 is equal to 5. We have a common denominator, so we get 15 over 3 equal to 5, and then 5 equal to 5. So in this case, for this problem, undoing multiplication or division first simplified the math in some way. We were able to get rid of fractions in the first step. Again, in most cases, undoing addition or subtraction first is the best practice. But sometimes undoing multiplication or division may simplify your math a bit. Let's practice a few more. So the first step here will be combining like terms. We have the variable x raised to the first power, and then another variable x raised to the first power. So these are like terms that can be combined. So we have 18 equal to, so 4 times 4 is 16 plus 1. We end up with 17x all over 4 minus x over 4 plus 2. So this is 17x minus 1x. So we have 18 equal to 16x all over 4 plus 2. And then we can simplify that fraction down. 16 divided by 4 is 4. So we have 4x plus 2. There's no reason here to undo that multiplication first. So we'll subtract 2 from both sides. We have 16 equal to 4x. And then divide by 4. And we end up with x equal to 4. When we check our answer, we go back to that original equation. So we have 18 equal to 4 1/4 times 4 minus 4 over 4 plus 2. This is 18 equal to, I'm going to go ahead and just convert this back into an improper fraction. So we have 17 over 4 times 4 minus 1 plus 2. These 4s are going to cancel out. So we have 18 equal to 17 minus 1 plus 2. 18 is equal to 17 minus 1 is 16 plus 2 is 18. And then finally, 5 minus 2y equal to 9. Subtracting 5 from both sides, that is negative 2y equal to 4. Then we divide both sides by negative 2. And we end up with y equal to negative 2. Checking the answer, we get 5 minus 2 times negative 2 is equal to 9. This is 5 minus 2 times negative 2. That is negative 4 equal to 9. Subtraction of a negative is addition of a positive. So that's 5 plus 4 equal to 9. And then 9 equal to 9. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. For this first problem, we will undo this addition of 2 by subtracting 2 from both sides, leaving 13 equal to 8 over 10. So we're dividing by 10, so we'll multiply both sides by 10, resulting in A equal to 130. For the second problem, 11 is subtracted from B, so we will add 11 to both sides. Gives us negative 4b equal to 32. We'll undo this multiplication of negative 4 by dividing by negative 4, resulting in b equal to negative 8. As in previous lessons, I have not been checking the answers in these practice problems, but do always go back and plug that number back into the original equation to check your work. In this case, we'd have negative 4 times negative 8. That is positive 32. Positive 32 minus 11 is 21. In the third problem, we have 15c over 2 minus 7c plus 2 equal to 5. We can combine this like term. This leaves us with c over 2 plus 2 equal to 5. So the next step is to undo that addition by subtracting 2 from both sides, ending up with c over 2 equal to 3. And then we'll multiply both sides by 2, resulting in c equal to 6. And finally, we have addition of 7, so we'll undo that by subtracting 7 from both sides. We get 5/3 d equal to 25. So dividing by 5/3 is the same as multiplying by 3/5, and we end up with d equal to 15. Continue practicing solving equations, and I'll see you in the next video.